This is TWiT.
Now, I know that there are some hardcore geeks in our audience. I mean, that's what the TWiT army is all about. But do you think maybe those hardcore geeks have given a thought to eggs? Specifically, I'm talking about what eggs are. I mean, let's all think about it. We've all had eggs in our life, unless you've got some weird egg allergy. And we all know that if you open up an egg in its raw state, you're going to get some gelatinous goop along with the yolk. And that gelatinous goop, for some reason, when you cook it, when you heat it up, it becomes solid. Now, I'm sure some of those hardcore geeks, those members of the TWiT TV army, have probably put a couple of cycles of brain power into that, figuring out why it changes when it's heated up. Now, the easy answer is to say, well, because you cook it. When you cook it, it's going to look like that. But the far more interesting answer is also far more intelligent. Now, egg white is made mostly of protein. That protein is the food source for an embryo that's contained within a fertilized egg. In its raw state, that protein stays bonded in amino acid strings, and that's why an egg yolk is so slimy and stringy. But when you heat those proteins, you get two effects. The first is that as the heat slowly rises, it breaks apart those amino acid strings. And, well, those amino acid strings are then, as the heat continues, turned into stronger bonds. That's right. It becomes a protein mass. That's why a boiled egg contracts from the shell, because the hardening of that mass and the breaking down of those amino acids actually expels water as lysosome. I'm totally missaying it. It's an enzyme is expelled from the protein mass. Now, that's interesting, and that probably answers a question or two for some of us who have wondered about eggs for any number of reasons, but it may not be all that important unless you actually take a look at science. Now, there have been some geeks, specifically some researchers from the University of California, Irvine, and I believe it was Flinders University in Australia, who figured out a way to unboil an egg. Yeah, folks, I'm not making up that word. That's true. They've actually figured out a way to reverse the process, to turn a cooked egg with that protein mass that has expelled water and that enzyme back into that gelatinous goop. Now, again, cool. And I'm sure that many people in the TWiT TV army would love to see that process, but most normal people would say, why would I want to unboil an egg? Well, aside from freaking science, the answer is that our future may very well be determined by that unboiled egg. You see, what these scientists figured out is that if you can reverse the process, if you could heat the protein mass and cause the proteins to break back apart and reform those bonds that were first created by the amino acid strains, that you could create something that could be manipulated. In their paper, they described a device that would pull apart the tangled proteins from their strong bonds and allow them to reform weaker bonds. The process starts with eggs boiled for 20 minutes at 90 degrees Celsius. Then they soak those egg whites, that hardened egg white, in urea. That liquefies the solid material and recreates the clear protein lysosome. The protein pieces are still unusable because they're tangled, but at the end, they get original unboiled proteins by running it through basically a centrifuge. It's a spiral machine. They squirt the tangled proteins into that, and at the end of the process, they get an unboiled egg white. Again, very cool, but why should we care? We should care because that very well may be the future of biomed. You see, when we start talking about some advanced treatments, specifically treatments for cancer that require custom proteins that can form antibodies that will attach themselves to cancerous cells, you need these untangled proteins. And it's very difficult to make them. Right now, they can make them on an incredibly small scale using chicken ovaries, basically. They can't get a lot of them, which means that the process is incredibly slow and incredibly expensive. This new process that these researchers from the University of California, Irvine, and in Australia have come up with not only makes the process cheaper, but it makes it faster on an order of thousands and thousands of times faster than the old process. That means mass-produced, custom-made proteins, which means maybe if we come up with a cure for cancer, we can give thanks to breakfast.